Now that the user has logged in to a client workstation, Venus will establish an RPC session on behalf of the client. And in order to establish the RPC session, the following message exchange is going to happen. And this is what is called the bind operation between the client and the server. So what Venus is going to do is send the client identity and an encrypted cipher. The client identity, as I mentioned earlier, in private key crypto systems, you have to send it in clear text so that the server knows the identity of the client. And in order to establish a new RPC session, Venus will use the secret token as the client identity, and it will use the HKC, the handshake key for the client, that was contained in the clear token data structure that was given back to the workstation by the server as part of executing the login process. That is the key that will be used for encrypting the starting message for the RPC session establishment. Now, what exactly is the message that is being sent? Well, all that is sent for initiating this RPC session establishment is a random number, which is new for each RPC session that Venus is establishing on behalf of this client. Every time it wants to establish a new RPC session within a login session, it creates a new random number and encrypts it using the handshake key. That's the ciphertext, and the secret token is the client ID, and that's the message that goes from Virtue to Vice, the server. So when this message arrives at the server, how will the server decrypt this message? Well, the client ID is a secret token. Recall that the secret token is nothing but an encryption of the clear token with a key that is known only to the server. And therefore, what the server can do is take the secret token, decrypt it using the key that it has, and once it decrypts it, it gets this clear token data structure, and from that clear token data structure, it can say, well, what is the key that is contained in this clear token data structure? Take the key and decrypt this message, because that key is HKC. And that is how the server can get the message that has been sent as the initiation of the RPC session. So in particular, what the server has gotten now is the random number that was sent to it by Venus, XR. Now what the server does is it takes this random number, increments it by 1, and also adds a new random number, YR, and that is the message that it is going to send back to the client. It has to encrypt this message, of course, because it is going on the wire, which is insecure. So it's going to encrypt it using a key, a handshake key, which we'll call HKS. And by design, HKC and HKS are exactly the same. So in other words, whatever is the handshake key that has been given to the client in the clear token is the same handshake key that the server is going to use to communicate information back to the client as well. So it encrypts this message with this handshake key and sends it over to the client. So what is the purpose of this message? When this message comes over to the client can decrypt this message. How? It's going to use HKC, which is the handshake key that it knows will be used by a genuine server to encode the message and send it to the client. And so it can use HKC to decrypt this message. And once it decrypts this message, it gets these two numbers. There's XR plus 1, that is the original random number that this guy sent over to the server, incremented by 1. Now, what is the purpose served by this number XR plus 1? It actually establishes to the client that the server is genuine. Anybody could replay a message that they see on the wire, but for this message to have the right content, what the client is expecting is that the response that the client is going to get for the original message that was initiating the RPC session is that the response from the server is going to contain a number that is 1 greater than the random number that it sent the server in the first place. So if this number XR plus 1 is what the client was expecting, then it establishes that the server is genuine. So this goes back to what I said about authentication of the server. That is one of the challenges that the Andrew system has. This is the way the Virtue workstation, the Venus process on the Virtue workstation on behalf of the client can establish the genuineness of the server that this workstation is talking to. Or in other words, it's not a Trojan horse that is sending this message, but it is genuine server that is sending this message because this field is exactly what Venus expected it to be. Now what is this number? This is another random number that the server is sending as part of this message. Why is it sending this random number? It'll become clear in the next set of communication that's going on between Venus and Vice. Now once Venus has extracted this YR from this message, what it is going to do is it is going to increment it by 1 and take that as the message, YR plus 1 as the message, encrypt it using the handshake key and send it over to the server. And when the server decrypts this message and extracts this field, it'll see whether this field is what it is expecting it to be. What the server is expecting is that this will be YR plus 1. And if the client is genuine, then the client would have been able to extract YR from this response that came from the server and generate YR plus 1 and send it over to the server. So in other words, this message coming to the server is establishing the genuineness of the client. Because this original message that we saw could have been just a replay, meaning somebody sniffed the network, got a hold of this packet, and replayed it. But if they replayed it, then they would not have the key and they would not have been able to decrypt this message. So the fact that the client was able to decrypt this message, extract YR, increment it, and send a new message that contains YR plus 1 to the server is authenticating to the server that the client is genuine. Just as this message established to the client that the server is genuine, similarly, this message coming from the client to the server is establishing to the server that the client is genuine. And this pair of communication that you're seeing is also avoiding replay attack, either from the client to the server or from the server to the client. In both directions, we are avoiding it by this trick of generating a new random number for establishing an RPC session and communicating it back and forth between the client and the server.